Hello dear students, I hope you are fine and doing well in your studies. Students, today we are going to start from where we have finished in the previous session. Student, in this session, we will do some basic questions, examples, theorems, which are important regarding to this chapter. So, let us begin with the chapter itself. To solve tan theta is equal to 2, now we can write tan theta is equal to tan alpha, where tan alpha is equal to 2, and you can say alpha is equal to tan inverse 2. And what is the solution of the equation tan theta equals to tan alpha? It is theta is equal to n pi plus alpha. The solution of the equation will be theta is equal to n pi plus tan inverse 2. This is the solution of given equation tan theta is equal to 2. Let's see one more example. We have to solve cos square theta is equal to half. This is the type of cos square theta is equal to cos square alpha. We can write cos square theta is equal to 1 by root 2 whole square. What is the value of 1 by root 2? It will be cos square pi by 4. Now the equation is cos square theta is equal to cos square pi by 4. Then the solution is theta is equal to n pi plus minus pi by 4, where n belongs to integer. This is the general solution of the equation cos square theta is equal to half. Students, everywhere in this chapter, n taken as an integer if not stated otherwise. The general solution should be given unless the solution is required in a specified interval or range. Students, now we are going to study types of trigonometric equations. Type first, trigonometric equations which can be solved by use of factorization. Example is here. Solve 2 sin x minus cos x into 1 plus cos x is equal to sin square x. Now 2 sin x minus cos x, 1 plus cos x is equal to 2 sin square x. Now transfer the 2 sin square x into left hand side and write down sin square x as 1 minus cos square x and factorize it. It is the 1 minus cos x and 1 plus cos x. Now 1 plus cos x is a common factor, it is here, and after solving, this is the remaining part, because if 1 plus cos x is common, then it is 2 sin x minus cos x minus 1 minus cos x, means it is the 1 plus cos x. Cos x and cos x are cancelled and it is 2 sin x minus 1 is equal to 0. If 2 factor is equal to 0 means a into b is equal to 0, then either a is 0 or b is 0. So we can say 1 plus cos x is equal to 0 or 2 sin x minus 1 is equal to 0. This implies cos x is equal to minus 1, and as we know, it is x is equal to 2n plus 1 pi, and if sin x is equal to half, then sin x is equal to sin pi by 6, and it is theta is equal to n pi plus minus 1 to power n is here, where n belongs to, and alpha is here also, and it is n belongs to integer, where what is the alpha? The value of alpha is pi by 6. You can write alpha is equal to pi by 6, and the solution of this side is x is equal to 2n plus 1 pi, where n belongs to integer, and this is the combined solution of this equation, and mention alpha is here also, or you can write pi by 6 is here. This is the type first, use of factorization to solve trigonometric equations. Students, it is type 2, trigonometric equations which can be solved by reducing term in quadratic equation. What is the meaning of this? We have to see one example here. 2 cos square x plus 4 cos x is equal to 3 sin square x. Now sin square x on the left hand side and write down sin square x as a 1 minus cos square x, and now this equation is the complete equation of cos x. Now simplify it. It is the 5 cos square x plus cos x minus 3 is equal to 0. After using the 𝕍𝕀𝔻𝔼ℝ formula, we can find the roots of this equation, and the roots will be -2 plus root 19 by 5 and -2 minus root 19 by 5. Because cos x lies between -1 to 1, that's why cos x is equal to -2 minus root 19 by 5 is not the solution. Equation second will be true if cos x is equal to -2 plus root 19 by 5. This is the alpha. And you can say if cos x equals to cos alpha, where cos alpha is equal to this. And the solution of cos x is equal to cos alpha is x equal to 2n pi plus minus alpha, where alpha is cos inverse, is the inverse, -2 plus root 19 by 5. This is the example of type 2 trigonometric equations. Students, here is the type 3 trigonometric equations which can be solved by transforming a sum or difference of trigonometric ratios into their product. What is the meaning of this? In the cos 3x plus sin 2x and sin 2x and sin 4x, now we can use the formula of sin c minus sin d, and by using that formula, the sum and difference can be reduced to their product. Here cos 3x is here, and we are going to apply the formula of sin c minus sin d here. It is 2 cos c plus d by 2 into sin c minus d by 2. Then cos 3x is a common factor. Cos 3x is here. It is 1 minus 2 sin x is equal to 0. Now here also the product of two numbers is 0. Then either one number is 0 or other number is 0. If cos 3x is equal to 0, then 3x is equal to 2n plus 1 pi by 2 here. And x is equal to 2n plus 1 pi by 6. And if sin x is equal to half, then x is equal to n pi plus minus 1 to power n pi by 6, and answer is here. This is the type 3 of trigonometric equations. Now students, here is the type 4, the trigonometric equation which can be solved by transforming a product of trigonometric ratios into their sum or difference. This is the reverse of type 3. Here sin 5x and cos 3x can be converted into the summation formation, means we have to multiply 2 and use the formula of 2 sin into cos b, and after providing this system, it will become sin 8x plus sin 2x is equal to sin 8x plus sin 4x. Now solve it, and after solving we can find that sin 4x minus sin 2x is equal to 0. Now apply the formula of sin 4x, it is the 2 sin 2x into cos 2x minus sin 2x is equal to 0, and now it is the fundamental form. Product of two numbers should be 0, then either one is 0 and other is 0. If sin 2x is 0, then 2x is equal to n pi and x is equal to n pi by 2. This is the one solution. And if cos 2x is equal to half, then 2x is equal to 2n pi plus minus pi by 3. And after simplifying it, we can find x is equal to n pi plus minus pi by 6, where n is the integer. And here are the solution of this question. This is the type 4. The students now see type 5 trigonometric equation of the form a sin x plus b cos x is equal to c, where ABC belongs to real number, can be solved by dividing both sides of the equation by under root a square plus b square. Let's see one example here. Solve sin x plus cos x is equal to root 2. We have to divide by under root a square plus b square. Then what is the a? A is 1 and b is also 1. Divide both sides by the equation by root 2. We get sin x into 1 by root 2 plus cos x into 1 by root 2 is equal to 1. 1 by root 2 can be written as sin pi by 4, and this 1 by root 2 can be written as cos pi by 4. This is the formula of cos a minus b. Cos a minus b is equal to 1. Then this 1 can be written as in terms of cos theta. What is the value of cos theta for the 1? It is 0 degree. Then what is the solution of cos theta is equal to cos alpha? It is the 2n pi plus minus alpha, means theta is equal to 2n pi plus minus 0. That's why the calculation is here. X minus pi by 4 is equal to 2n pi. Now solve it. It is x is equal to 2n pi plus pi by 4, and this is the general solution of given equation sin x plus cos x is equal to root 2 by this method. Students, trigonometric equation of the form a sin x plus b cos x is equal to c can also be solved by changing sin x cos x into their corresponding tangents of half the angle. We have to remember the formula that sin x is equal to 2 tan x by 2 upon 1 plus tan square x by 2 and cos x is equal to 1 minus tan square x by 2 upon 1 plus tan square x by 2. Let an example, 3 cos x plus 4 sin x is equal to 5. In this example, we have to introduce the formula of cos x and sin x in terms of half angle of tangent. The equation will convert into 3, 1 minus tan square x by 2 upon 1 plus tan square x by 2 plus 4, 2 tan x by 2 upon 1 plus tan square x by 2 is equal to 5. Now let tan x by 2 is equal to t and equation second convert into 3 times 1 minus t square upon 1 plus t square plus 4, 2t upon 1 plus t square is equal to 5. Now solve this equation, we obtain the quadratic equation in terms of t is here and finally it is 2t minus 1 whole square, from where we can easily find out t is equal to half. Now what is the t? As we know, t is the tan x by 2, means tan x by 2 is equal to half. Now we have to apply the trigonometric equations. Tan x is equal to tan alpha. So we are going to write tan alpha is equal to half, means equation is like this, tan x by 2 is equal to tan alpha. What is the solution of tan x is equal to tan alpha? It is x equal to n pi plus alpha. Here x is the x by 2. So x by 2 is equal to n pi plus alpha. After simplification, we can find x is equal to 2n pi plus 2 alpha, where alpha is tan inverse 1 by 2 for n belongs to integer. Students, now we are going to study type 6. Trigonometric equation of the form P, it is the function equation sin plus minus cos x comma sin x into cos x, means equation contain this term and product of sin x and cos x, where P is a polynomial can be solved by using the substitution sin x plus minus cos x is equal to t. Let here one example, sin x plus cos x is equal to 1 plus sin x into cos x. Now we are going to solve this question and find the solution of the trigonometric equation. So we are going to assume that sin x plus cos x is equal to t. Squaring this system, we find that sin square x plus cos square x plus 2 sin x is equal to t square. Then after simplification from this equation, we can find that sin x into cos x is equal to t square minus 1 by 2. What is the 1? The value of sin square x plus cos square x is equal to 1. Now put the value of sin x plus cos x in terms of t. We can find whole equation in terms of t. Equation in terms of t will be t square minus 2t plus 1 is equal to 0. It is the t minus 1 whole square. And from this equation, we can find t is equal to 1. What is the t? T is the sin x plus cos x. Now sin x plus cos x is equal to t and we can solve this equation by type 5. Type 5 is here. Divide and multiply this equation by 1 by root 2. We can obtain this equation and now we can easily solve this equation. It is the cos x minus pi by 4 is equal to cos pi by 4. Cos theta is equal to cos alpha. Then theta is equal to 2n pi plus minus alpha. If we take positive sign, then we can get x is equal to 2n pi plus pi by 4. If we take negative sign, then we get x is equal to 2n pi. These are the answers of this equation. Now type 7 is the trigonometric equations which can be solved by the use of boundedness of the trigonometric ratios sin x and cos x. Let's see one example here. Solve sin x into cos x by 4 minus 2 sin x plus within a bracket 1 plus sin x by 4 minus 2 cos x into cos x is equal to 0. Now simplify it. We have to multiply sin x in this bracket and it is the sin x into cos x by 4 minus 2 sin square x plus cos x plus sin x by 4 into cos x minus 2 cos square x is equal to 0. Now sin x into cos x by 4 plus sin x by 4 here into cos x and minus 2 times sin square x plus cos square x plus cos x is equal to 0. Now we can use the formula of sin A plus B. It is the sin into cos B plus cos A into sin B. It will become sin pi x by 4 and sin square theta plus cos square theta is equal to 1. It is minus 2 here and it is plus cos x. Now after simplification we can find sin 5x by 4 plus cos x is equal to 0. Now here we can use the boundedness of the trigonometric ratios sin x and cos x. Now equation second will be true if sin pi x by 4 is equal to 1 and cos x is equal to 1. The solution of sin theta is equal to 1 is 2n pi plus pi by 2 and the solution of cos theta is equal to 1 is x is equal to 2m pi. After solving this equation we can find x is equal to a10 plus 2 upon 5 into pi where n belongs to integer and from there x is equal to 2m pi. Now we are going to generalize the answers. Means we want to give the answer in the one variable. For that we have to equate both x or you can say equation third and fourth. After equating the equation third and fourth we can find the relation between n and m here. Now we are going to put the value of m and find the value of n. Let for n is equal to 1 we can find m is equal to 1. For m is equal to 5 then n is equal to 6 and so on. If m is equal to 4p minus 3 where p is integer then we can find n is equal to 5p minus 4. General solution of given equation can be obtained by substituting either m is equal to 4p minus 3 in the equation 4 or n is equal to 5p minus 4 in the equation. The general solution of equation is 8p minus 6 pi where p belongs to integer. This is the solution of type 7 trigonometric equations. Students, regarding of this chapter, there are some important points. Point number 1. Many trigonometrical equations can be solved by different methods. The form of solution obtained in different methods may be different. From these different form of solutions, the students should not think that the answer obtained by one method are wrong and those obtained by another method are correct. The solutions obtained by different methods may be shown to be equivalent by some supplementary transformation. To test the equivalence of two solutions obtained from two methods, the simplest way is to put the values of n is equal to 0, 1, 2, 3, minus 1, minus 2, etc. and then to find the angle in 0 to 2 pi. If all the angles in both solutions are same, then solutions are equivalent. Point number 2 is here. While manipulating the trigonometrical equations, avoid the danger of losing roots. Generally, some roots are lost by cancelling a common factor from the two sides of an equation. For example, suppose we have the equation tan x is equal to 2 sin x. Here by dividing both sides by sin x, we get cos x is equal to 2. This is not equivalent to original equation. Here the roots obtained by sin x is equal to 0 are lost. Thus, in place of dividing an equation by a common factor, the students are advised to take this factor out as a common factor from all the terms of the equation. Point number 3 is here. While equating one of the factor to 0, take care of the other factor that it should not become infinite. For example, if we have the equation sin x is equal to 0, which can be written as cos x into tan x is equal to 0. Here we cannot put cos x is equal to 0 since for cos x is equal to 0, tan x is equal to sin x upon cos x is infinite. Point number 4 is here. Avoid squaring. When we square both sides of an equation, some extraneous roots appear. Hence, it is necessary to check all the solutions found by substituting them in the given equation and omit the solution not satisfying the given equation. For example, consider the equation sin theta plus cos theta is equal to 1. Squaring, we get 1 plus sin 2 theta is equal to 0 or sin 2 theta is equal to 0. That implies 2 theta is equal to n pi and theta is equal to n pi by 2. This theta gives theta equal to 0, pi by 2, pi, 3 pi by 2 and so on. Verification show that the pi and 3 pi by 2 do not satisfying the equation as sin pi plus cos pi is minus 1. It is not equal to 1. And sin 3 pi by 2 plus cos 3 pi by 2 is equal to minus 1. It is not equal to 1. The reason for this is simple. Equation number 2 means this equation is not equivalent to first, and 2 contains two equations, sin theta plus cos theta is equal to 1 and sin theta plus cos theta is equal to minus. Therefore, we get extra solutions. Thus, if squaring is must, verify each of the solution. Point number 5 is here, some necessary restrictions. If the equation involves tan x, sec x, take cos x is not equal to 0. If cot x or cosec x appears, take sin x is not equal to 0. If log appears in the equation, means log f theta appears in the equation, then use f theta greater than 0 and base of log greater than 0 and is not equal to 1. Also note that within a square root f theta is always positive. For example, square root sin square theta is equal to mod sin theta, not plus minus sin theta. It is very important point. Now students, point number 6 is here, verification. Students are advised to check whether all the roots obtained by them satisfy the equation and lie in the domain of the variable of the given equation. Student, let's see some examples here. Solve 7 cos square theta plus 3 sin square theta is equal to 4. We have to convert cos square theta in terms of sin square theta or sin square theta in terms of cos square theta. Write down here 7 cos square theta plus 3 1 minus cos square theta is equal to 4. Now simplify it. 7 cos square theta minus 3 cos square theta is equal to 1 and it is 4 cos square theta is equal to 1. Cos square theta is equal to 1 by 4 is equal to 1 by 2 whole square. Now we have to write down the solution of cos square theta is equal to cos square alpha. Theta is equal to n pi plus minus alpha. What is the alpha? Alpha is pi by 3 where n belongs to integer. This is the general solution of this equation because we can write 1 by 2 as cos pi by 3 whole square. Student, let's see one more example. Solve tan theta plus pi by 3 plus tan theta plus 2 pi by 3 is equal to 3. Now we are going to apply the formula of tan a plus b here and tan a plus b here. It is the tan theta plus tan a plus tan b upon 1 minus tan a into tan b plus tan a plus tan b whole upon 1 minus tan a into tan b is equal to 3. Now what is the value of tan 60? It is the root 3 and tan 120 degree, it is the minus root 3. Now the equation will convert into tan theta plus root 3 upon 1 minus root 3 tan theta plus tan theta minus root 3 whole upon 1 plus root 3 tan theta is equal to 3. Now taking LCM here, it will become tan theta times 1 minus 3 tan square theta plus tan theta plus root 3 times 1 plus root 3 tan theta plus tan theta minus root 3 times 1 minus root 3 tan theta whole upon 1 minus 3 tan square theta is equal to 3. After simplify it, it will become 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta times 3 is equal to 3. Now simplify it, it will give tan 3 theta is equal to 1. You can say it is equal to tan pi by 4, means 3 theta is equal to n pi plus pi by 4. Now you can simplify it. Theta is equal to 4n plus 1 times pi by 12, where n belongs to integer. This is the general solution of this equation. Students, we are going to study solving simultaneous equations. Here we will discuss problems related to the solution of two equations satisfied simultaneously. We may divide the problem into two categories, two equations in one unknown or two equations in two unknowns. Students, let's see one example here. Find the smallest positive values of x and y satisfying the equation x minus y is equal to pi by 4 and cot x plus cot y is equal to 2. Now simplify the cot x plus cot y is equal to 2. Cot x can be written as cos x upon sin x plus cos y upon sin y is equal to 2. It will become sin y into cos x plus cos y into sin x is equal to 2 sin x into sin y. Now simplify it. It is the sin a plus b is equal to 2 sin a into sin b. The formula of 2 sin into sin b is cos a minus b minus cos a plus b. Now simplify it. Cos x plus y plus sin x plus y is equal to cos x minus y. Now taking cosine in equation first, means x minus y is equal to pi by 4. Cos of x minus y is equal to cos pi by 4. The value of cos pi by 4 is 1 by root 2. This equation will convert into cos x plus y plus sin x plus y is equal to 1 by root 2. Now we can solve this equation by a cos theta plus b sin theta form. We have to divide both sides, or you can say multiply by 1 by root 2. Cos x plus y plus 1 by root 2 sin x plus y is equal to half. Now it is cos a cos b plus sin a sin b. The formula of cos x minus b a minus b, here it is x plus y minus pi by 4 is equal to 1 by 2. 1 by 2 is written as cos pi by 3. Then what is the solution of cos theta is equal to cos alpha? It will give theta is equal to 2n pi plus minus alpha. Now it is the equation number 2 and equation number 1 is here. After solving equation 1 and 2, we can find for n is equal to 0, x plus y is equal to 7 pi by 12 and x minus y is equal to pi by 4. After solving these two equations, we can find the least values of x and y. Here x is 5 pi by 12 and y is pi by 6. Question is find the smallest positive values of x and y. For finding the smallest value, we substitute here n equal to 0.